So remember, oxidation means a loss of electrons. Reduction means gain of an electrons. Our oxidation means an increase in oxidation number, and reduction means a decrease in oxidation number. And oil rig can help you remember. Oxidation is loss. So we were working on this example. We ran out of time before I could show. So we had zinc, which is solid, mixed with hydrochloric acid. And that makes zinc chloride and hydrogen gas. So according to our rules, an element by itself will have an oxidation number of 0. Hydrogen will have an oxidation number of +1. The most electronegative element, which is chlorine, will have an oxidation number equal to its charge. So over here, it will have an oxidation number equal to its charge. So that'll be -1. And the sum of these has to equal 0. So we have two -1 charges, or two -1 oxidation numbers. And so zinc plus the -2 has to add to be 0 because there's no charge on this compound. That means zinc has to have an oxidation number of +2. Thus, we can see zinc is going from neutral to zinc 2+. And hydrogen is going from H+ to hydrogen gas. This is more easily seen if we do the ionic form of this. Well, so in the net ionic form of this equation, so this is the full balanced equation. So zinc is a solid, so writing the net ionic equation, zinc is a solid, so it's not an ion. Then we have H+ and Cl negative. Over here we'll have Zn2+ and chlorine negative. And this is not an ion, so we just write it down normally. This would be aqueous, that would be aqueous, that would be aqueous, that would be aqueous. So this isn't the full one yet. What is the spectator ion in this? Which one doesn't contribute to the overall reaction? which one is still on both sides unchanged? This goes from a solid to an ion. We have chlorine and chlorine. So our net ionic equation is zinc solid plus H plus goes to zinc 2 plus, which is aqueous, plus hydrogen gas. We have to still balance it. We need 2 hydrogen here to make the hydrogen gas over here. This would be the net ionic equation. In net ionic equation form, it is very obvious what our reduction and our reduction and oxidation is. We see zinc going to 2 plus, and we see hydrogen going from H plus to H2. Hello? Yes, she is. All right. She needs to go to the office and leave. But before you leave, I just go ahead and pass this out. I want y'all to do a writing assignment. It's not that formal. I want it not written. It needs to be handwritten. Can't be typed. Basically, I want some experiment ideas that we can do at the end of the year. Just look up some fun chemistry experiments y'all like to see performed. Don't do like dissolving a brick of gold. It's outside of the school's budget. Don't do anything too crazy, like maybe a giant big fireball, or TNT or nitroglycerin. Something that is relatively safe, can be done in a lab or perhaps outside. Write the chemical formula, chemicals needed, and describe the setup and what you would expect to learn from it and see. On the back, I gave an example I wrote in less than 10 minutes from purely memory. Note, this technically isn't a chemical experiment, but Mentos and Coke is an example. It doesn't have to be this long or detailed, but it's an example of basically what you could do to write. Do at least 2 different experiments. I prefer many, because I'm going to need to start ordering the chemicals. And I plan the last 6 weeks us doing a lot of experiments and being in the lab mostly. But I need it by Friday, and it needs to be handwritten and dated. So, from this equation, we can see zinc is oxidized. From zinc metal to zinc 2 plus ion. It is losing electrons, or its oxidation number is increasing. Each H plus ion is being reduced to combine to H2 gas. So its oxidation number is reducing from +1 on each atom to 0. So H plus is the oxidizing agent, while zinc is the reducing agent. So let's do another example. So let's start with the balanced equation. We have 2KBr, which is aqueous, mixed with chlorine gas. Chlorine can dissolve in water. It's aqueous. Potassium chloride, a salt substitute. It's aqueous. And bromine can dissolve in water. It's also aqueous. So, potassium. What group number is it in? So group 1 always has +1 oxidation numbers. Bromine is the most electronegative element in this compound. What is the charge on bromine when it becomes an ion? Yes. So its oxidation number is -1. Chlorine is by itself. So 0. Again, over here, we have the exact same situation. Potassium is group 1, so it's +1. Chlorine is the most electronegative, so it's the charge, which is -1. And what would be the charge over here? Or the oxidation number? 0, because it's by itself. So, which ones have changed? We've gone from 0 on chlorine to -1. And we've gone from -1 on bromine to 0 here. Another way of doing this is to look at the net ionic form. So calcium bromine will break apart into K plus and Br negative ions. Chlorine is not ionic, so it will stay as chlorine gas. This will break apart into its ions, K plus and chlorine Cl negative. This is not ionic, so it will stay as Br2. We can see that potassium is the spectator. So that is the spectator. It's on both sides of the equations and is not used in any non-ions. Which means the overall net ionic is Br negative plus, and that will be aqueous, plus chlorine, which is a gas or technically aqueous, plus chlorine, plus bromine. And we need 2 bromine and 2 chlorine to balance it out. Regardless of which way you do it, we see that bromine is going from -1 to 0, and chlorine is going from 0 to -1. So that makes bromine oxidation or reduction. So reduction means you're gaining an electron. When you gain an electron, you become more negative. So it's being oxidized. Another way of thinking about it is the oxidation number is increasing. And this would thus be reduction.
The more reduction becomes,
you're reducing the number. Or you are gaining gaining electrons. So rig means reduction is gaining electrons, and oil oxidation is losing electrons. Another way to look at it is reduction reduces the oxidation number. And oxidizing increases it. So here it shows this problem that we just did. To see how oxidation numbers change, start by assigning numbers to all elements in the balanced equation. There is no change in the oxidation number of potassium, so it's called a spectator ion. And what we see is chlorine is being reduced by -1. It's going from 0 to -1, so it's reduction. And to go from -1 for bromine to 0, we have to add 1, so it has a +1 oxidation. This is another way of looking at it. So if you're really practiced, and I'll write down the formula. I'll ignore the aqueous. You can see that chlorine has 0 and -1. So that means we're going from 0 to -1 by subtraction. We are subtracting 1. And bromine is going from -1 to 0. So to do that, we have to add 1 to go over here. So chlorine is a reduction because we're subtracting 1. And bromine is oxidization. This means that chlorine is the oxidizing agent. It oxidizes the bromine. So chlorine is reduction. So chlorine undergoes reduction. And is the oxidizing agent. It oxidizes the bromine. Bromine is reduced. Bromine is oxidized. Undergoes oxidation. And is the reducing agent. it reduces the chlorine. So this is a cause and effect scenario. Bromine is being oxidized because chlorine is oxidizing it. The reason bromine is oxidized is because chlorine has oxidized it. So chlorine is the oxidizing agent. Chlorine is undergoing reduction because bromine has reduced it. That makes sense? So let's try another one. This will be from not the net, but just a ionic equation. What is oxidized? And what is reduced? Oh, and this is net. This is net ionic. So what is being oxidized? So iron is going from 3 plus to 0. How's it doing that? By subtracting 3. This is decreasing. This is also, how do you go from 3 plus to 0? How many? By adding or losing electrons? By gaining electron. This is reduction. It's being reduced. What is being oxidized? Aluminum is going from 0 and 2 plus 3. So it's increasing an oxidation number, or it's losing 3 electrons. So aluminum is being oxidized. What is the oxidizing agent? So aluminum is oxidizing itself? Iron is oxidizing aluminum. What is the reducing agent? Maybe aluminum. Aluminum is reducing iron. The reason why iron is reduced is because aluminum is reducing it. What is the spectator ion? That's an O for oxygen. And the oxygen is a spectator ion, or oxide, to be more precise. So aluminum is oxidized and iron is reduced. Aluminum is the reducing agent and iron is the oxidizing agent. That's out of order. Spectator iron is oxygen. So, half reactions. The oxidation process and the reduction process of a redox reaction can each be expressed as a half reaction. For example, consider the unbalanced equation for the formation of aluminum bromide. This is unbalanced. Out of curiosity, what would be the balanced equation? So we have aluminum plus bromine 2 makes aluminum bromide. So where would you put the 3? So we have one aluminum on the left and one aluminum on the right. So you can make this little table if it helps. Personally, I can just see it and do it in my head. So we have aluminum on the left, and these should be bromine, Br. So I have one aluminum on the left, one aluminum on the right. I have 2 aluminum on the left, and 3 bromine. 2 bromine on the left, 3 bromine on the right. So these numbers don't match. So what is the least common multiple of them? If you had to multiply something to them, what number can you get? What do they have in common? 6. What do you need to multiply by 2 to get 6? So I'm going to multiply this by 3. And now we have 6 on the left. And I'm going to multiply this by 2. That changes bromine to 6, but it changes aluminum to 2. So now bromine is matching, but aluminum is not. So I need to double the aluminum. And now we have it matching, so the balanced equation is this. 2 aluminum for 3 bromine, 2 makes 2 aluminum bromide.
I put the 2 would affect, 3 would be I thought 2 would affect.
So we don't have to have the fully balanced equation to do these problems. However, the half reactions, it's actually better to not do the full equation. So we'll start with there. So let's analyze this. We have aluminum by itself. So its oxidation number is what? We have bromine by itself. So its oxidation number is? Which one of these is more electronegative? Br. And what is Br's charge? So that means it's be 1 negative for charge, but the oxidation number would be -1. And these is a neutral compound. So what must aluminum be to make this neutral? So we have 3 times -1. So this means aluminum must be +3. Make sense? So aluminum is gaining +3. And bromine is losing 1. So which one is our oxidation? Which one is increasing in oxidation number? This one is increasing by 3. It is, this is very easy to get confused on, I do admit. But aluminum is oxidation. And this is how we can write or a half reaction. So our half reaction will be aluminum is going to aluminum 3 plus. Or, yeah, 3 plus. How's it doing that? How does it go from no charge to 3 plus? By doing what? Well, in respect to other electrons. It's gaining electrons or losing electrons? Electrons are negative. So it's going from having all of its electrons to becoming an ion and giving up 3 electrons. So the 3 electrons is splitting away from the aluminum, giving this 3 plus. So bromine is reduction. So the half reaction would be bromine having no electrons is somehow having, this is B2, I need 2 over here, is getting a negative charge. So how does it go from no charge to a negative charge? So I'm going to add to it an electron. But I have 2 bromines, so how many electrons do I need? 2. So this is the half reaction for the reduction. So bromine is gaining 2 electrons to become Br negative. And we have to balance the numbers on this. Aluminum is losing 2 electrons, and we never have a minus sign. If you think of it as aluminum minus 3e, we can never have a minus. So to make this equation balance, we have to move this over to the other side. It's one way you can think of it if you're thinking of it in algebra. We can never have a minus in the equation. So oxidation half reaction shows the loss of electrons by aluminum, and the reduction half shows the gain of electrons by bromine. So basically equations where you gain electrons, so oil rig, reduction is gain. Reduction is going to have it gain electrons. Oxidation is loss, that's the oil part. Oxidation is going to show a loss of electrons. Do y'all know what explosives are? Yeah, bombs. Do you know what they all have? let's look up. Oh, what is that truck bomb? It's potassium nitrate mixed with diesel. What's it stand for? Info. It's ammonium nitrate, not potassium. So, looking up explosive bombs, you will notice every single type of explosive bomb requires one thing: an oxidizing agent. How explosive it is depends on how good the oxidizing agent is. This is almost every single type of thing depends on its oxidation agent. Do y'all know what thermite is? It is aluminum. It is aluminum rust. It's aluminum oxide. It's just rust and aluminum. Let me put it that way. It's just aluminum and rust. So you take a lot of rust, iron rust, grind it down into a very fine powder. Take a lot of aluminum, grind it down to a lot of really fine powder. Mix them together, you have thermite. The oxygen bonded onto the iron would like to jump over to the aluminum. And whenever something is being oxidized, it produces a lot of energy. Any type of fuel source, any type of thing when you're burning something, is being oxidized. And by the way, this was the equation for it. This is thermite. We have aluminum powder. We have iron oxide, iron 3 oxide. The oxygen is jumping off of the iron and going to the aluminum. This causes the aluminum and iron to change charges. When one is oxidized and the other is reduced, a release of energy happens, and they can be quite high. What's it called? Danger triangle? The very first week of school, and that's not what I was looking for. Danger safety triangle? Or is it just safety triangle? Oh, what was it called? Hazard triangle? I'll have to honestly pull up my very first lab safety thing. Just Googling it. Oh, it's called a diamond, not a triangle. That's the reason why. Safety diamond. I always think of it as a triangle because the bottom one is. So you'll notice, and let's see if I can actually find it. If you ever look at these, the white one is always going to be special. You get a very own special warning, OX. If it's a strong oxidizer. If it has an oxidizing agent or reducing agent in it, you get this own warning. That means it can explode if given enough energy or mixed with something. This is basically an explosive warning if you see OX on it. Anything that strongly oxidizes something else, a strong oxidizer, can explode quite violently. Like this one is probably the worst thing you can see. Maybe some reactivity symbols here. Don't touch with water. Strong oxidizer. Very corrosive. Very flammable. Very toxic. So last thing. Do y'all know of any experiment y'all like off the top of y'all's head? So look up some things. It doesn't have to be that formal. But I did handwritten and with a date on it. I went by Friday. Elephant toothpaste is something I'm planning on doing. Do y'all know what that is? You can. Just talk about it a little bit. The only problem is hydrogen peroxide breaks down over time, and you have to have it quite pure. Which is why you can't do this experiment and buy all the chemicals at the beginning of the year. I think it's 30%.
This is the brand new Guinness World Record largest ever elephant toothpaste foam experiment. In today's video, which is partially sponsored by LastPass, I'm going to walk you through everything we had to go through to get to.
So his is a special elephant toothpaste.
Some really cool science discoveries we made in our hundreds of
His isn't true elephant's toothpaste.
The main ingredient for elephant's toothpaste is hydrogen peroxide. It's the same stuff you pour on a scrape to disinfect it. The thing is, the bonds that hold the hydrogen and oxygen together are pretty weak.
And I'm fairly well, maybe so. That's probably not store-bought.
If we poured some of this in here and just left it for a while, it would keep releasing oxygen and eventually you'd be left with just water. However, if you add a catalyst like potassium iodide, you can make that slow process happen almost instantly. So that's cool, but we can make it way more impressive if we add one key ingredient. Soap. So if we pour this in and then do everything else the same, now when the oxygen is released, the soap captures it, creating bubbles and foam. And then finally, if you do all that again, only now you add food coloring and use a flask that tapers like this, you can focus the expansion of foam so it looks maximum awesome.
That's elephant's toothpaste. I plan on doing that. Try to find several. I mean, you might find something really interesting, and I'll order the chemicals and we'll do it.